get 1. This interval, the one thing you have to be careful with, on the original one, it has a equal to bar. I don't know if I can put an equal to bar here, and that's what I'm going to have to wait and decide. So I'm going to leave it off for now. I got to show you how we check that. Then I go to the middle function. Well, the derivative of that middle function is just 2x. The interval is between 0 and 2. They didn't have equal to bars, so I don't know if I should put them, so I'm leaving them off. The third piece, the derivative of a constant, is just 4. So the derivative of 4 is 0. Any constant is just 0. Again, I'm not going to put that equal to bar down here because I don't know if the derivative exists. Okay. In order for the derivative to exist, the two places I have to check at x equals 0 because I don't know if I should have an equal to bar, and I have to check at x equals 2. One way to do this would be to check to see if the derivative from the left equals the derivative from the right. So basically, I'm checking like the left derivative, and I need to know, does that equal the right derivative? Does the slope from the left equal the slope from the right? Now, the mathematical notation would be I'm taking the limit as x approaches 0, because that's the number I'm checking, from the left, so the left would be the negative side of g prime. I want to know, does that equal the limit as x approaches 0 from the positive side of g prime? Is the slope from one side the same as the slope from the other side? So if we're plugging in 0 from the negative side, we'd be on this function, but there isn't an x to plug in, so that limit is 1. If I'm approaching 0 from the positive side, I'd be on this interval, but if I plug 0 into there, I'd have 2 times 0, so that's 0. So these do not equal each other. So therefore, it is not differentiable at x equals 0. Okay, so this was for 37. So I'm kind of answering 36 and 37 together. So it's not differentiable at x equals 0, which means on 36, when I wrote it, I cannot have an equal to bar there. Neither of those can have an equal to bar because the derivative does not exist at 0. If I check at 2, I'm going to do the same thing. I'm going to take the limit as x approaches 2 from the negative side of the derivative. So notice I'm writing g prime. And I want to see, does this equal the limit as we approach from the other direction? Well, 2 is the second 2 functions. If I plug 2 in from the left, so from values less than 2, I'd have 2 times 2, so this side is 4. If I plug 2 into here, well, there's nowhere to plug in an x, so it just stays 0. Again, those two don't equal each other, so it's not differentiable at x equals 2. Now, if you had done question, I think it was 30, where it asked you to graph it, you would have noticed from the graph that it's not continuous at x equals 2. So if it's not continuous at x equals 2, you could have skipped this, because if it's not continuous, then it's not differentiable. So you wouldn't even have to check the derivative, because it has to be continuous in order for the derivative to exist. So on 36, your answer is this piecewise function. And again, you cannot have any equal to bars because the derivative didn't exist at those values. And then on 37, you're stating that it's not differentiable at those 2 points. Okay, so I just wanted to make sure that you guys saw that one because that's one that will come up. All right, let's look at related rates. So at first, it looks a little overwhelming. I'll tell you, the first few problems of these, students are always a little bit stressed out because they're story problems. We tend to get more nervous with story problems. The list of steps that we do, this is a pretty long list of things that we have to go through. So the first few times it seems a little bit overwhelming, but I will say after a few days of it, we end up being really good at them. They're not as scary as they seem on the first day. So your assignment today will be pretty short. It's just going to be questions 1 through 8 because the questions are a little bit time consuming. So just keep that in mind as you're working the problems. One problem does take a bit of time. All right, so I'll explain these steps, but I'll come back to them pretty frequently. So one thing you're going to do a lot is draw a figure. So with every question, pretty much, you're going to have to draw some figure. We're going to do a lot of geometry. So your figure might be a triangle, it might be a cylinder, it might be a rectangle, it might be a cone, but you're going to have some figure, and then you're going to choose some variables. So if you have a triangle, maybe you call the sides A, B, and C. If you have a cone, you'd be working with the radius and the height. Okay, so you're going to introduce some variables. You're going to write what's given. So identifying what's given would be like you're given dv dt. So sometimes pulling out this information is tough. And when we do everything, we're taking the derivative with respect to time. So with related rate questions, up to this point, we've taken the derivative with respect to x. Like it's always dy dx. Today, it's going to be dy dt and dx dt. So the denominator will be with respect to time. We're going to write some equation. Some of the equations, I would say we probably do Pythagorean theorem more than any other equation. We do a lot of right triangles. So you're going to use Pythagorean theorem a lot. You're going to use volume equations a lot. You could use area of a triangle or a rectangle, but it's generally some geometry equation that you're going to introduce. Okay, if a quantity is changing, then it must be represented with a variable. Let me give you some basic example. There's a really common related rate question, which is you have a ladder leaning against a wall. Okay, so here's a ladder, it's leaning against a wall. Let's say the ladder started to fall. Let's say that this bottom edge of the ladder started to fall away from the building. As that bottom edge of the ladder falls away from the building, the top falls down, right? So those two things would be changing. So I could call this side X and this side Y. A lot of times I would draw an arrow, like I might draw an arrow that that side is going down and this side is going out. So those lengths are ones that I'd use a variable because those sides of the triangle are changing. Like that triangle isn't stationary, right? The triangle is changing sides. But let's say the ladder was a 25-foot ladder. So if it was a 25-foot ladder, I could label that 25 because that it's not like the ladder is changing inside. So that's what this is saying. If a quantity is constant, then you could call it a number. The 25 is constant. The ladder is not changing length, but the other two sides are. So I have to call those a variable. I couldn't call them 12 or 10. I can't put in a number because they're changing values. So when it says draw a figure, your figure might look something like that. Different information, but something along those lines. Okay, then we look for a secondary relationship. This would just be more equations. So maybe if they told you one variable, you could find the other one. We're going to do implicit differentiation. So the calculus that we're doing today is pretty much the same exact calculus and derivatives that you've been doing in the last 2 days. The last 2 days, though, we've been writing dy dx. Today, it's just going to be dy dt or dx dt. Okay, so dt on the bottom. So that's the big difference is it's with respect to time. So anytime we say with respect to time, that's where we put the dt on the bottom. Then we're going to substitute numbers and solve and write a sentence explaining the meaning. We'll come back to that. So this first example is kind of an oversimplified. This one is giving us all of the information without the story problem. So it's great. I would never ask you one this easy on a test, but it gives us a chance to focus on the math and not the story problem. So we're going to do that first, then we'll introduce the story problem. So they tell us in this problem, the first 3 steps of the procedure are done because they've identified all of the information that we need. We only need to complete the last couple. So we need to, we really need to complete the last 3 steps because we have to do implicit differentiation and then solve. So they've given us, they're telling us that dx dt. Now, if I think about this in words, like what this is saying, dx dt, this is saying the change in x. So d always just stands for the change. Okay, so this is the change in x with respect to the change in time. What this would be saying is, imagine x, if I'm just thinking of like an x-axis, a particle could be going left or right. If dx dt is negative, then it's probably going to the left. The change in the x direction is -6. Okay, so this is telling us how the x value is changing with respect to time. So as time goes on, the particle's moving to the left. So that's the information that we're told. They're telling us some specific y value. So at the moment when y is 4, and then they're giving us a relationship between x and y. They want us to find dy dt. So the first thing we're going to do is we're going to take the derivative of this equation. So let's start with xy. What rule do we have to apply to take the derivative of x times y?
Product
rule, thank you. So product rule is going to be first times the derivative of the second. The only thing, again, that's different is we're taking the derivative of y, but this time with respect to time. So instead of writing dy dx, we just write dy dt, because we want the derivative with respect to time. So that was first times the derivative of the second plus the second times the derivative of the first. The first function is x, so we take the derivative of x, but we're taking the derivative with respect to time. So unlike your last couple assignments, it was dx dx, so we didn't have to write it, but this time, since there's a t on the bottom, we have to write the dx dt. And then the derivative of 12 is 0. Okay, so again, the calculus, the differentiation is really exactly the same as what we've been doing. We're just writing dy dt or dx dt. All right, now at this point, what I always do is I kind of identify the thing I want to find. They want us to find dy dt. So this is the thing I'm supposed to solve for, meaning I won't have a number to plug in for that, but I should have a number to plug in for every other variable. Well, they told us y equals 4, so I know I'm going to plug 4 in there. So I know what to plug in for y. They told us dx dt is -6, so I know I'm going to plug in dx dt there. So the only thing that stands out to me is I don't know what to plug in for x. Can I figure that out? Could I figure out what to plug in for x? What do you think, Colby? What could I do?
If you plugged in all the other numbers, then you could just move everything else to one side and then have x equals whatever. All the
okay, so are you talking about this equation?
Yeah.
The reason why we can't use this equation is we don't know this one. But you're on the right track. Is there another equation I could work with?
You could put, you could put dy dt to one side.
That's where we're going to go. So I think you're one step ahead. Maggie, okay. It looks like you might have a thought. What do you think, Maggie?
You could plug in 4 and y for the x times y equals 12.
Perfect. So we're going to plug, since we know the y value, we can plug the y value in here. So we'd have x times 4 equals 12, divide by 4, so x is 3. So we're going to use the original equation to solve for the piece that that wasn't explicitly told to us, but now we know what to plug in. Now we can do basically what you were saying, Colby. So I can plug in 3 for x. I don't know dy dt, so I'm going to leave that one as the variable. I know y. They told us y was 4. I know dx dt because they told us that was -6. And now we can solve for dy dt. So now we know everything, so we can move everything across. So let's do that to -24. I'm going to go ahead and add 24. So I'd get 3 dy dt equals 24, divide by 3, so dy dt equals 8. That's what we were asked to find, and we were able to find it. Okay, now I want to talk about what this might mean. This question didn't really give us any context. There was no story problem, but they're saying this is the change in y. So think y typically, y goes up and down. So if dy dt, the change in y with respect to time is 8, they're saying that the particle is moving up. So at this moment, the particle must be moving up at a rate of like 8 units per second or whatever the units are. And dx dt was negative, so it's moving to the left and it's moving up. So it's telling us how it's changing in each of those directions with respect to time. Okay, let's try another one. This next one, though, gets a little bit more difficult. They help us out because they draw a picture. Sometimes we have to come up with a picture on our own. But we have to find all of that information. We have to find what rates are given, what rate are we trying to find, and what other information are we given to help us do this. So they're telling us a windlass is used to tow a boat to a dock. So this boat is approaching the dock as the rope gets pulled in. The rope is attached to the boat at a point 15 feet below the level of the windlass. So this side is 15. Like, this is not going to change. So it's attached right here. As the boat comes in, this side doesn't change, X changes, and the rope length changes. Not bad. So the reason why it's okay to leave this one as 15 is because that's a constant rate, meaning that side length, that side of the triangle is not changing in size. But this side does change, so we have to call it a variable. This side is changing because the rope is being pulled in, so we have to call it a variable. Okay, then it tells us if the windlass pulls the rope in at a rate of 30 feet per minute, so I want to focus on this. The units are kind of the dead giveaway for me. Once I see feet per minute, those are units of a rate. So I know that I'm going to say, okay, 30 equals, or let me start again, some rate, so d something dt has to equal 30. So focus on units. If you focus on units, that's going to be super helpful. Our units were feet per minute. I like to write the units as a fraction because then I can say, okay, well, minutes, that's a unit for time. So that's why dt is on the bottom. Feet, that's a unit for distance. Well, the 30, they're talking about rope, and the rope, they're calling the letter z. So I'm going to call this dz dt. So it's the rate of change of the rope. So you have to identify, like in this notation, what rate it is. Are we okay with us calling that dz dt? Okay, so then I'm going to continue. Here's the question. It says what rate? So they're asking us to find some rate. A rate is always d something dt. So I know they want us to find d something dt. They want the rate at which the boat is approaching. Well, the boat, as it approaches, that's x. So they want us to find dx dt. So how quickly is that boat coming in? Every time you have a find question, it will always be find something, win something. Well, here's the win. So find that when there's 25 feet of rope. So I need to find when something equals 25 feet. When what equals 25 feet? What do you guys think?
Z?
Which one? Z. Yes, good. Very good. So it said 25 feet of rope, and the rope was letter Z. Okay. So now we have all of our information. So we're ready to try to find this. The one thing they didn't tell us that we can come up with pretty easily is an equation that relates everything. So what is an equation that's going to relate these three lengths together?
Pythagorean theorem.
Very good, thank you. And we're going to use a lot of Pythagorean theorem with these types of questions. So Pythagorean theorem, you square the legs, add them together, and that equals the square of the hypotenuse. So this is the equation that relates that triangle together. If we take the derivative, now again, let me emphasize, notice 15 is okay for me to label as a number because it doesn't change. I know z equals 25, but I don't want to plug 25 in right now because that's a changing distance. So it would have a derivative, like it does have a rate of change. 15 isn't changing, so its derivative is 0. It makes sense that the derivative is 0 because it's not changing in length. When I take the derivative of x squared, I'd get 2x, but we have to attach that dx dt because we're taking the derivative with respect to time. So every single variable this time has that little piece attached, dx dt, dy dt, dz dt, whichever the letter is. So the derivative of z squared is 2z dz dt. Okay. At this point, after I've taken the derivative is where I kind of evaluate what it is I'm trying to find, and then I hope I know everything else. We're trying to find dx dt. So this, I'm not going to have a number to plug in, but my hope is that I know everything else. So if I look at this, I know z, they told us that was 25. I know dz dt, that's 30, so I know what to plug in there. I don't know x. Is it possible for us to find x? Think about how we found it on the last one. Is it possible for us to find x at this moment when z is 25?
Yeah.
Yeah, what would you do, Kara?
You plug in 25 to the z squared, the 15 squared plus x squared equals z.
Perfect. Good. So we know this. We can just plug in 25 for the z, so we plug it into the original Pythagorean theorem. So 15 squared plus x squared equals 25 squared. If we solve this, we'd get x squared equals 400 and x equals 20. So now we know what to plug in for x. So generally you have to do some work to find one of the variables, but it's not a lot of work. You just have to use the given information in the equation. So now I can say, okay, let's see what we've got. We have 2 times 20 because x is 20. Dx dt, that's the thing I don't know, so that one stays the variable. 2z, they told us was 25. And they told us dz dt is 30. Oh, and I just thought of something. I wrote dz dt as 30, Is Z growing in length or shrinking in length as the boat comes in? Very good. Yes. So let me back up to answer David's question. He has a good question. Over here, when we took the square root, you're correct. We always have a plus or minus. So technically, it is x equals plus or minus 20. The reason why I only have to consider positive 20 is because x is referring to a length, and so I only have to consider the positive. So it can only be a positive length. So that's why I only have to consider the positive. There's one other place I want us to consider a sign, though. Is this rope length, is it getting bigger, or like, is it increasing in length, or is it decreasing in length as the boat comes in?
Decreasing.
Decreasing. Everybody okay with that? So this rope length is decreasing. So because it's decreasing, decreasing should have a negative. So I really need to add a negative to that 30. So that length, the rate of change is that it's decreasing. So I need to have it be a negative 30, which means in here, I need to make sure I put a negative with that 30. Okay, we'll talk more about that on our final answer to see if our final answer makes sense. So now it just is algebra. I'm going to bring this all the way over here since I'm kind of running out of space. So I have 2 times 20. So on the left, I have 40 and then dx dt. On the other side, I have 50 times 30. So what is that? Right? 50 times 30. Yep, that'd be 15 with 2 zeros. And then our last step, we would divide by 40.
Wouldn't it be negative?
Thank you. It is negative. I almost lost my negative again. You're right. Because it was a negative 30. So then negative 1500 divided by 40 gives us 37.5. So we get these cancel out. We're going to get dx dt equals negative 37.5. Your answer has to include units. Okay, so I'm going to scoot this over a teeny bit more. So I have to include units with this answer. As I'm deciding on my units, I look at this. I need units for x over units for t. X was this length. How are we measuring the distance between the boat and here? What units do we use? Feet. Very good. This would be feet. And then the denominator units are time. So we have to say, okay, well, how are we measuring time? In this question, we were measuring time in minutes. So this answer is feet per minute. Why do you think this answer is negative? Why is this rate negative? And does it make sense? Does it make sense for the rate of change of x to be negative in this question?
Because the distance is smaller, the closer you get.
Exactly. So as the boat's coming in, because the boat is coming in, x is shrinking. So yeah, x is a decreasing rate, so it makes sense that it's negative. So the last thing you're supposed to write is like a sentence. It doesn't have to be a full sentence. I'm okay with, we want to do as little writing as possible. But I would say in this, and I'll be maybe a little bit more explicit. So I'll say the boat is approaching, and you can say this in a few different ways, is approaching the dock, or I guess they're calling it the windlass, at a rate of 37.5 feet per minute. This would be acceptable. I didn't say the word negative. I didn't say the word decreasing, but I said approaching. So that would be acceptable. Another way you could have said it is you could have said the rate of change of the boat. Well, I wouldn't even say that. I'm going to just leave it at that for now. So that's one way you could have said it. Not too bad. Okay, take a second on 3. 3 is our last example we're going to do together today. It will take a second, but I'm going to give you about 1 or 2 minutes. Read that question, try to draw a picture, and see what information you can pull out from it. Okay, so I'm going to give you 2 minutes to get started on problem 3. I think the hardest part is drawing the picture and identifying the information. Let's see what we can come up with. Okay, so at least my picture, do you guys have something similar? So I like to use letters that remind me of what each side is. So I used P for the police car and C for the car. Okay, so I have the police, it said the police is traveling south towards an intersection. So I drew the arrow. I like to have arrows. I know that the police officer is driving in this direction. And then it said a speeding car is traveling east. So the car is traveling this way. It's driving away from the intersection. So again, I want to have that arrow. It's a changing distance, so I call it a variable. So this side is changing and this side is changing. Then it says when the police officer is 0.6 miles from the intersection. So this statement right here, I would write P equals 0.6 miles. The car is 0.8, so I'll say C is 0.8 miles. So those are like two the moment at this time that we're concerned with. It says the policeman's radar shows the distance between them. The distance between them, I'm calling that Z. So the distance between them would be this, like the hypotenuse of this right triangle. Okay, and they're saying it's increasing, which means it'd be a positive rate at 20 miles per hour. So when I see 20 miles per hour, I'm going to write 20 miles per hour. Writing a rate with the units stacked on top of each other like that, I think helps us decide what like rate to call it. The denominator is time, so I know for sure it's a d something dt. I just have to figure out what letter goes on top. So based on my picture, my letters being C, P, and Z, and yours could be different if you chose different letters. What rate is that 20? That's d what dt?
Is it Z?
Z, perfect. Okay, so we have a dz dt. So this is all of our given information. And then it says if the speed of the police car is 60 miles per hour, I guess we still have more. So I have 60 miles per hour. Again, the units tell me it's a rate. So when I identify this, I know it's a d something dt. What letter goes on top if this is the speed of the police car? This is d what dt. P, C, or Z? What do you guys think?
P. Is it P?
P. Very good, Lauren. Yep. So this is P for me. I chose P for police car, and you could have chosen a different letter, which is why your picture is important. Okay, so dp dt is 60 miles per hour. Now you have to ask yourself, anytime you have a rate, is that a positive 60 or is it a negative 60? Is P, this length that I'm calling P, is that length increasing or decreasing over time?
Decreasing.
Decreasing. Very good, Gregory. So I'm going to add a negative to that because I know that that distance is decreasing. Okay, then the question is find the speed of the car. Well, the speed of the car is really just equal to dc dt. That's the rate of change of the car with respect to time. Not too bad. So this is what we're asked to find. We're asked to find this rate. So far, I think what we've done is the hardest part of the question. I think the hardest part of these problems is reading the question and pulling out all of the information. Once you've pulled out all of the information, then actually finding the stuff isn't that difficult. The only thing we're still missing is an equation that relates all of this. What do you guys think? Is there an equation that will relate P, C, and Z together?
Pythagorean theorem.
Exactly. We're going to do a lot of Pythagorean theorem. So P squared plus C squared equals Z squared. I want to point out one difference between this question and the previous question. In the previous question, we were able to leave the 15 as a number. The reason we were able to put that number in is because this side didn't change as the problem changed. In this picture, all three sides are changing length. Like the triangle, all three sides are changing. So all three have to stay variables. Then we take a derivative. Derivative of P squared is 2P, and we attach a dp dt. We treat every variable the same. So when we get to C, C squared becomes 2C, but we have to attach a dc dt. We get to Z, well, Z squared, its derivative is 2Z dz dt. So we take the derivative and we say that's implicit differentiation, where we're just adding on those differentials. Okay, We are asked to find dCdt. So this is the thing I'm trying to find. I should have a number to plug in for every other variable. Well, they told us P is 0.6, so I know what to plug in there. They told us C is 0.8, so I know what to plug in there. They told us dz dt, so we know what to plug in for that. And they told us dp dt. So what's the only variable we have to figure out on our own?
Z.
Z. Very good, Lauren. So to find Z, when I try to find Z, I'm just going to go back to Pythagorean theorem, which was the p squared plus c squared equals z squared. But they told us P and C, so I can plug in 0.6 for P and 0.8 for C, and now we can find Z. This is like a 3, 4, 5, like a double of a 3, 4, 5. So Z, if you use a calculator or whatever, you're going to end up getting 1. Again, it would be a plus or minus 1, but because we're talking about a length, we get to call that length of the triangle as 1. So now we know what to plug in for Z. So at this point, I know it's just a bunch of like arithmetic and algebra. So I'm going to take this, I'll write it up over here. So we have 2 in place of P. P is 0.6. dp dt, they told us, was negative 60. Then we have plus 2 C. C was 0.8. And you guys please stop me if I do something silly. dc dt, that's the thing we don't know. So that's the one thing that we leave as the variable. It equals 2 times Z. So 2 times, let's see, Z we found to be 1. And dz dt, they said, was 20. It's all curvy. My goal is to solve for dc dt. So we need to multiply 2 times 0.6 times negative 60. I'm going to use a calculator. So if I multiply those, I get 72, but there was a negative, so this is a negative 72. Then I have plus 1.6, 2 times 0.8 is 1.6, dc dt. On the other side, 2 times 1 times 20, I get 40. Everybody okay to hear? Then I'm just going to add the 72. So I'd have 1.6 dc dt equals the 40 plus 72, so that gives us 112. We'll divide that by the 1.6. And I end up getting dc dt equals 70. What are my units? 70 what? When you decide, look at your C and your T. This is where we follow it. C, go back to our picture. C was this distance. How are we measuring distance in this question? How are we measuring length?
Miles.
Miles, exactly. So we know the units on top is miles. The units on the bottom are units of time. So in this question, time is being measured in hours. So this is why it's 70 miles per hour. I got a positive rate, which I would expect because C is driving away from the intersection. C is getting bigger, so it makes sense that my rate is positive. So in words, if I were to write a sentence in terms of what this is saying, it says, what is the speed of the car? So I would just answer by saying, the speed of the car is 70 miles per hour. That's how fast the car is traveling. And that's it. Okay, so we're going to save example 4 for tomorrow. So your assignment is 2-4A. You guys just have questions 1 through 8. 1 and 2 are like the first example. There's no story problem. They just give you the values. You take the derivative and they go pretty okay. Then they ease you into the story problems. This first story problem is really just telling you have a circle and it's telling you the units. So you are expected to know how to find the formula for area of a circle and circumference of a circle. If you've forgotten them, do a quick Google, they'll come up really fast. Then it asks you about a balloon, but again, they give you volume equations, so you're given that. So your assignment is just 1 through 8. So I will stop here. I want you guys to kind of practice these before I do too many. So your quiz on Friday, just as a reminder, let me show you, I've got this up. So your quiz on Friday, It's here, it has BC Unit 2 Quiz 2. It says motion, implicit, and related rates. So these first set of questions, 1 through 8, are fair game for your quiz on Friday. So motion, I could ask you position, velocity, acceleration. Implicit, that's implicit differentiation. So that was our last 2 days that we've done, and then today is that related rates. So just kind of a heads up, I haven't written it yet. That's why it says 0 points. It will be worth like 30 points, but I haven't decided if it's multiple choice or free response, but I'll let you guys know that for sure tomorrow. So that's all I have today. So I will let you guys go and work. Remember, you do have the extra credit available this week. So if you want to meet with a group right now, you're welcome to go ahead and meet with your group. You have to do 20 minutes. So you could do that today. You could do it tomorrow. Just make sure you do it before the quiz on Friday so that you're prepared for the quiz. So if you're good, you can sign out. If you have an individual question, you can stick around. I'll probably leave this Google Meet open just for a couple more minutes. So
Thank you.
have a good day,
Thank
guys.
you.
Thank you.
Bye.
See ya. See you, Grace.
Hi, Ms. Brown. So I just have a quick question. So I tried to submit the derivative of trig functions worksheet.
Okay.
And that same night, Xfinity decided that would be a perfect night to shut down our Wi-Fi and do maintenance.
Yeah.
So I went back in to try to submit it the next day, and I don't know if it just glitched out or something, but it won't let me submit it.
Okay.
There
Let me
anything
pull it
that
up and we can just put in the points. Let me open up my grade book really quick. And you said it was the derivative of all trig, that worksheet?
Yeah. I have it right here if you want to see it.
Let's see. Okay. Did you get them all finished? Did you earn all 40 points?
Yeah.
Okay, perfect. So what I found is I can enter in the points manually sometimes on your end. It still doesn't show that it's been submitted because you haven't actually submitted it, but it will give you a score. So when I sync to Skyward, it will be fine. But on your end, it might still show that it hasn't been submitted, but I did record your points, so you're good now. So thank you.
Thank you so much.
No problem.
Just ignore my email.
Okay, I will. And I'm glad you would rather say this because sometimes I see the emails and I forget. So please don't. So good. Okay.
All right. Well, thank you for today.
No problem.
Yeah.